Okay, so let's go to number 23. Now, unlike number 22, we want to find the probability for x, not z. So we have a normally distributed random variable, but we don't have a standard normal distribution here. So the first thing we've got to do is use our z-score to standardize this 42. All right, so let's use our z-score. We'll have z is, on top, we'll have our 42 minus our mean of 46 divided by 4. And if we do that calculation, that's going to be negative 4 on the top divided by 4, which will give us a z-score of negative 1. So now we're looking for z being less than negative 1, and we can use our Excel to do that, just as we did for the ones in number 22. So let's go to Excel. And I still have my calculations in there from that. So we're going to do our norm.s distribution here. We're going to put negative 1 in and true. And it tells us that is 0.1587. All right, so let's go back here. And so we're going to get for the actual probability 0.1587. All right, now let's notice this one's greater than, but we can still go ahead and proceed with our z-score calculation. 48.5, I need to put that in parentheses, minus the mean of 46 divided by the standard deviation of 4. And if I put that into my calculator, I get 0.625. Now be careful, that's not our probability, that's our z-score. That's what we're going to need to put in to find our probability. And recall, if it's greater than, we're going to go ahead and look up our probability for a z-score of 0.625, but we're going to have to subtract that probability from 1 to get our actual answer here. So 0.625. All right, so we'll have equal norm, and I'll put 0.625 in there, and the word true, and it tells me 0.7340. So 0.734 subtracted from 1. And the actual probability we want is 0.266. All right, now, for C, just like we did up here for this one, we're going to have to look up both values, but first we need to standardize them. So we're going to have to do our z-score twice. So we're going to do 44 minus the mean of 46 divided by 4. And we'll see what that answer is. And then over here, I'll just take it a little further here. We're going to do our 47.2, oops, equal. Our 47.2 minus our 46 and divide by 4. So this first one is going to give us a negative 2 divided by 4, which will be negative 0.5. And this second one's going to give us 0.3. Now remember, those are not our probabilities. Those are our z-scores. So we need to look both of those values up, see what the probabilities are, and subtract them from one another to get the probability of being between two values. So we'll look up the 0.3 and the negative 0.5. All right, so equal norm.s.dist. And I'll look up the 0.3 first because I know that's going to be the bigger probability. That's 0.6179. So this will be 0.6179. And we'll subtract off what we get for the negative 0.5. So let me go back and get that. Equal norm.s.dist negative 0.5, true, and that gives us 0.3085. Now let's just subtract those two probabilities and we'll have our answer, and that gives me 0.3094. All right, let's go to 24, which we will see is sort of just the same thing. It just gives us a situation rather than just probability calculations without a particular situation involved. So the amount X of T in a bottle labeled 16 ounces, is normally distributed with a mean of 15.9 ounces and a standard deviation of 0.05 ounces. A can is selected at random. We want to find the probability that that can contains at least 16 ounces. Now, let's realize at least means that what we're looking for is that X is greater than 16. Or equal to, greater than or equal to, but of course that will end up being the same calculation in our normal probability, whether it's equal or not. Alright, so let's actually first do our z-score, and then because this is greater than, realize when we look up our z-score, we're going to have to subtract from 1 to get the actual probability. Alright, so our z-score is going to be 16 from our problem minus 15.9 our mean divided by the standard deviation of 0.05. And let's just do that. And that just gives me 2. Now let's just remember that always our standard normal table in Excel gives us less than, not greater than. So we have to subtract from 1 to get any greater than probability. So right here, I'm just going to go ahead and start this as 1 minus whatever I get when I look up a z-score of 2. Alright, so we'll go to our table here. Equal norm.s.dist. Let's look up 2. True. And it's 0.9773. Alright, so 0.9773. And again, let's do that subtraction. 0.0227. Alright, now let's look at part B. Now, part B is similar to what we did in part C in number 23. We want to find the probability that the can has between 15.8 and 16.1 ounces. Anytime we're looking for probability in between, we're going to have to find those probabilities and subtract them from one another. But this is not standardized yet, since our mean is not 0 and our standard deviation is not 1. So the first thing we need to do is our z-scores for both of these values. So our first one will be 15.8 minus the mean of 15.9 divided by 0.05. And I'll just sort of move over a little bit. We'll do our second one. Our second one will be 16.1 minus the mean of 15.9 divided by 0.05. Alright, so if I put the first one into my calculator, I'm going to get, I believe, -2, just looking at that. And then if I put the second one into my calculator, that's going to be +4. Alright, so now let's look up the two z-values of 4 and -2 in Excel, and we'll subtract those two proportions in order to get our answer. Alright, so we're going to do norm.s.dist, and I know the 4 is going to be the bigger one, so I'm going to go ahead and do that one first. That gives me a very, very large value. Now, this is close enough that we can go ahead and round it to 1 when we subtract it. So we'll have 1 for the first value. Alright, and then let's go ahead and equal norm.s.dist again. And our other value was -2. Alright, so we want to take 1 and subtract 0.0228. Alright, so our probability, and I'll just put a comma here, is going to be 1 minus 0.0228. And that's going to end up being 0.9772. Okay, so let's look at 25 now. The heights of women of a certain age are normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. What is the probability a randomly chosen woman of this age is chosen and has a height 70 inches or greater? So let's note that what we want here is the probability that X is greater than or equal to 70 inches. Now again, it's greater than, and our standard normal probability on Excel, or our process, only gives us less than. So we're going to have to subtract this from 1 eventually. But first, we need to standardize it. put it into our z-score formula. So we're going to have 70 minus the mean of 65 divided by the standard deviation of 2.5. And this will give us 5 divided by 2.5, which will give us 2. Now, as I recall, up here in A, we actually already looked up 2. So let's just save ourselves some work. When we looked up the probability for 2, it was 0.9773. And notice we had to do exactly the same calculation, 1 minus 0.9773. So just by coincidence, this turns out to be the same work, and we don't have to do that work twice. All right, so let's take a look at 26, and hopefully I'll have time to get to both of these. I think I can. All right, so for number 26, we want to find the value of z star that yields the probability shown. Now, notice here we already have the probability, so we're going to go backwards. Remember that our Excel gives us less than values. So here, really, all we need to do is go backwards, and whatever we get will be the correct z value. So let's put 0.004 into our norm.inverse function, and we'll get back the proper z value there. So, oh, I'm sorry, I lost track of my number there again. It was 0.004. Okay. All right, so equal norm, and this one we want to use inverse right here, and we want to put in 0.004, and it tells me that that z value is negative 2.652. All right, so going back, this gives us z star is negative 2.652, if I didn't lose it between here and there. Yeah, okay. Now, let's take a look at the second one. All right, so the second one, though, let's notice this is a greater than. And remember up here, in our last step, if we had a greater than, we always subtracted from 1. Since this process is going backwards in 26, we're actually going to subtract from 1 to begin with, and then look up what the z value is. So we'll have 1 minus 0.879 first. So that gives us 0.121. Now I'm going to put 0.121 into my inverse function in Excel. That will give me my z value. So equal norm.s.inverse 0.121. That's going to give me negative 1.17. So my z star is negative 1.17. Okay, so number 27, we can get A very, very quickly, and maybe I can get B before I run out of time here. I'm not sure. Scores on a national exam are normally distributed with mean 400 and standard deviation 25. Question A is actually quite easy. Find the score that is the 50th percentile. When we remember drawing our normal curve, the 50th percentile is always right in the middle, and on a normal curve, that is always our mean. So the 50th percentile is, oops, not 4,000, but 400. It's our mean. Now, for part B, we're going to have to do a little more work, and I see that I am running low on time, so I'm going to save that for the next video, just so that I don't run out of time to explain that.